in 30 minutes. Special Topics 2, Test 5. Okay, let's talk about this. A 5-speed manual transaxle has a fifth gear ratio of 0.95 to 1. Technician A says the transaxle output speed will be greater than the input speed in fifth gear. Technician B says the fifth gear is an overdrive gear ratio. Tell me who's right about that. 0.95 to 1 is what kind of gear? That means the output's going to turn faster than the engine, right? And what kind of ratio do they call that? Overdrive. You got it, overdrive. Everybody knows that.
So both of them are right.
That's a C. A CB. In a GM 2-mode hybrid electric vehicle, when can the vehicle be powered by electric power alone? In the first mode. During the first mode. Okay. The period of torque converter operation, where the turbine is turning at 90% of the impeller speed, is known as, that's the coupling phase. That's when everything starts turning together. Technician A says a torque converter clutch reduces slippage. Technician B says an auxiliary fluid pump is needed for the transmission to function during idle stop mode. Which technician is correct? Both those guys are correct. What are they talking about, auxiliary fluid pump? What is it that drives the pump in the transmission? The engine does. If you're in idle stop mode, you don't have any fluid pressure anywhere. It'd be kind of a drag, wouldn't it? So if you just, if you hit the gas and the engine starts up, and then the transmission's got to catch up. See, those have a regular transmission on them. Those. You remember the General Motors vehicle? Some of them got the big starter generator and a big wide belt on the front of them. They got a little bank of batteries in there in the back, like 36 volts or whatever, the blue cables and all that. And so those aren't really common around. You don't usually see those. But when you stop, it's kind of like a golf cart. When you stop, the engine dies, and when you put your foot on the gas, it takes off again. But the pressure is maintained in the transmission by the auxiliary fluid pump. That's not being driven by the engine, you see. And that's why it'll instantly be ready to pull. Otherwise, you'd have to wait until you filled everything up and it started pulling off. See, so you got to have that. That's something that I don't know if they figured that out, or if somebody, when they first built one, they realized it would jerk your neck off. All right. Let's see. Modifications to automatic transmissions used in hybrid vehicles include A, electric auxiliary transmission fluid pumps. B, modified torque converter lockup schedule. C, increased number of plates in multiple disc clutches. Or D, both A and B are correct. What do you think? That's number 5. That's D, both A and B are correct. Electric auxiliary transmission fluid pumps and modified torque converter lockup schedule. Got it? Alright, let me see here. Technician A says that power split continuous variable transmissions use a torque converter. Technician B says power split continuous variable transmissions use an electric transmission fluid pump. Which technician is correct about that? D. Neither one of them. All of the following statements concerning power split continuous variable transmissions are true except A. Power split CVT systems do not use a separate starter motor. B. The power split continuous variable transmission can operate in electric mode only. C. The ICE, what's the ICE? Internal combustion engine and motor generators are all connected through a planetary gear set. And D. One of the planetary members must be held to make the power split continuous variable transmission work.
D.
What do you think about that? That's a D. You got it? One of the planetary members must be held to make the power split CVT work. You know how we saw on these this little animation of the Toyota transmission I showed you, how that works. Now, do you remember what the various components are bolted to on one of those, like on a Toyota or Ford? The engine is bolted to which part of the planetary gear set in that transmission? Do you remember? Can you burn that in so you'll remember it and you can tell people?
The engine is connected to what?
What is the engine connected to in this CVT transmission that you have, like for the, you got 2 electric motors and you got the engine in the transmission on these hybrid Fords and Toyotas. Okay, so each one of these components is connected to a different part of the planetary gear set. Can you remember that? Each one of those, the engine is connected to a part of it, MG1 is connected to a part of it, and MG2 is connected to a part of it.
All different.
Yeah. Now remember this: the engine is connected to the planetary carrier. That's the part of the planetary gear set where the gears are. I mean, where the little planetary gears are. Okay. Now I get MG1 and MG2 crossed up, but as I remember, the bigger motor, the bigger electric motor in there, and I think that's MG2, is actually connected to the ring gear, and MG1 is connected to the sun gear. Now in some of your gear ratios, when you're driving this thing, there are times when the electric motors are turning backwards, but the internal combustion engine can never turn backwards. All it can do is stop turning. Okay, so you're basically driving different parts of that planetary gear set, sometimes backwards, sometimes forward, depending on what gear you want to be in. Now this is pretty complicated, isn't it? You don't really need to know all that other than the fact that sometimes the motors are running backwards and sometimes they're running forward.
Motors connected to the carrier.
Yeah, the carrier, which is the little planetary, it's got the little planetary gears. You know, the carrier is the little thing, it's got the little planetary gears spinning in it, on little pins. And the sun gear is the part in the middle, the ring gear is the part around the outside. And all three of these gears are connected to one another. All right, so basically your MG1, if I remember right, is that little motor. It's the one that starts the vehicle. MG2 is basically the one that pulls the vehicle down the road, whenever you need power. And of course, sometimes they work together. But the one that the big one, the big motor, is the one that windings are converted to a generator, so that when you hit the brake, converting that power goes, the momentum of the vehicle is actually driving that motor, and it's causing that energy that's being generated is going back to the battery. And if you do a lot of braking on those things, of course, it's maintained by the electronics. There's a ton of electronics in those cars, all different kinds of converters and that kind of thing, and engine and battery controller, this kind of stuff. And so there's a sensor module and a control module, and there's every one of them slightly different. But I've been driving one of those Ford Fusions, and I've seen the battery voltage when you stop a lot go up to 600 volts. It goes up really high, So, but anyway, just get that burned into your mind how that works, because we're teaching some hybrid stuff in here, and I want you to be totally duh-head about hybrid. And you remember how I could tell you could tell if a transmission on one of those Toyotas or Fords is bad? If you push the vehicle, like you don't just put it in where it'll roll. If you push it don't roll smooth. If it rolls like that means the transmission ain't no good. That's a simple diagnosis, isn't it? Okay. All right, so here we go. Let's see, number 8. Honda CVT is connected to the internal combustion engine with a what? How about a drive plate and a flywheel? You got that? You remember on the Honda, the motor is connected between the engine and the transaxle, which is kind of an interesting way they do that. Number 9, in a Toyota Lexus hybrid vehicle, how is reverse achieved? Does the engine run in reverse? No, it doesn't. The MG2 is used to power the vehicle in reverse. It uses the battery from power, and that, the bigger motor. Technician A says all automatic transmissions use planetary gear sets. Technician B says all continuous variable transmissions use torque converters. Which technician is correct? D is neither one of those. If it's a continuous variable transmission, it doesn't use a planetary gear set. If it's got the chain, the big chain that drives it, Any of you ever work on a go-kart? You ride a go-kart, you see the pulleys change. This pulley runs closer together, and that one runs farther apart, and it changes That's how some of these continuous variable transmissions work. Except they got a big ugly chain in them instead of a belt. But just keep that in mind. Let me see. Which one are we on? Technician A says the differential in a front-wheel drive vehicle is in the transaxle assembly. Technician B says the differential assembly is attached to the final drive ring gear. Which technician is correct about that? C. That's right. The transmission control module is responsible for what functions? Transmission fluid line pressure, shift quality, transmission shift points, or all of these are correct. That's D. All of these are correct. A scan tool uses bidirectional testing that allows the technician to send commands to actuators and observe signals from sensors. Well now, interesting. Not all scan tools use bidirectional testing. Remember I told you we've got that one big scan tool that does bidirectional testing. And what that means, you can go into special tests and you can tell the scan tool to make things happen. The other scan tools, little Nemesis scan tools that we got, you can read it, but you can't make nothing happen. That's they can read, but they can't make things. But bidirectional means not only can you read your PIDs, but you can go into another mode. You can tell it to do this, this, and this, and it can change things the way the engine runs. Number 14. How many primary designs of continuous variable?
No, be true or
False. Well, that's why it's a scan tool. You know, it just scans. But how many primary designs of continuous variable transaxles are currently being used in hybrid electric vehicles? B, 2. Which term describes the rate at which work is performed? Torque, force, horsepower, or inertia? C, horsepower. In the Honda belt and pulley CVT, which is what I was describing a while ago, Matt, how does the belt propel the vehicle? It pushes it. Got that? Anybody confused about that belt and pulley? At all? It's basically, you know, if you got those pulleys in there together, ordinarily, you know, think about the way that's going. If this is turning and you're going that way, it has to, you know, the way the thing is designed, it bites when you push and it releases on the bottom side. That makes sense? You know, there's a V-shaped chain looking belt. It ain't really a belt, it's a chain, almost like a transfer case chain, but it's got a distinctive shape that will work with those pulleys. And, you know, it does its biting and it does its, you know, power transmission whenever it stacks up when it's pushing, but it doesn't, you know, the pulling part of it. If you're trying to make it pull, it's going to slip. But if you push it the way they've got it designed, it works. You'd have to probably, you know, do a little bit of digging into that. But basically, it pushes the other pulley instead of pulling it. That's the way they've got them, you know, where it'll bite on that. That's why it's important to use rock granite wall on those things. You know, using there too. And whenever you've got one of the things that you learn when you're in school a lot is that, and it's not really a good thing either. If you're coming down to the wire and you're close to the end of, you know, the class session, you don't really like for any of your buddies to ask a question because it prolongs the class, you know. And I've seen classes like that where this one guy was really aggravating. And when everybody knew that we were almost done and we were going to head back home and it was noon on Friday, one of these 4.5-day classes, he would hold up his hand and start to ask a question, you know. I mean, that guy that was in that class with me one time, and I touched him on the shoulder, you know, no, shh, you know. He didn't really have a question. He was just wanting to aggravate everybody because he knew if he asked a question, that guy would launch into another 20 minutes of talk. Like, you know, that's what teachers do, you know, that's what we do. And so, okay. Yeah, we also tell stories that don't have anything to do with what we're talking about. Let's see. Technician A says a continuous variable transmission, an automatic transmission that does not shift gears, is an automatic transmission that does not shift gears. Technician B says a continuous variable transmission has a maximum of 6 distinct gear ranges. That is A. Just like a go-kart, it just, you know, goes on up from low speed to high speed. Which component listed below is not a part of a hybrid vehicle front-wheel drive transaxle? Differential, final drive gear ratio, transmission. All of these are included in the front-wheel drive transaxle. Now that is D. Okay. Okay, we've got 15 minutos here. Coolant circulates through all the following when the thermostat is closed except what? Heater core, water jacket, cylinder head, radiator. It circulates through all of these but one. Huh?
What's a water jacket?
That's actually the part in the engine around the cylinders and the heads and all in there. What does it not go to until the thermostat's open? Huh? Sir? Radiator. Good answer. You go, boy. All right. Technician A says oat coolants. What's oat stand for? Can you remember? Organic acid technology. You got it? organic acid technology. They're based on propylene glycol. Technician A says HOAT coolant stands for hybrid organic acid technology. Which technician is correct? 20, that's B. B. All of the following are examples of heat exchangers except A, condenser, B, evaporator, C, heater core, or D, thermostat. Huh? Thermostat, that's right. Coolant heat storage tank can keep coolant warm for a maximum of how many days? Now this is a bunch of hooey because I know better, but they're claiming that little thermos bottle on the Toyota that stores that warm water and it's supposed to be able to keep the head warm for a while. B says 3 days, but I've seen those things after a day and a half where they were cool enough to where you could, just if you spill the water on your hands, it wasn't even hot. Of course, don't go dumping water on your hand. Make sure that you give it the benefit of the doubt and say, hey, I may burn myself. Be careful. The coolant heat storage system is being discussed. Technician A says the water valve is driven by an electric motor. Technician B says the storage tank has its own electric water pump. Which technician is correct about that? That's both of those guys. Okay, and this we're talking about the little Toyota. The little Toyota that's got the little storage tank that stores the heat. It's like a thermos bottle, and it's got a little electric, pump that's driven by AC current. All of the air entering the passenger compartment must pass through the what? Radiator, heater core, evaporator, condenser. How about the evaporator, man? It's always going to go through the evaporator if the air conditioner's not on. It ain't going to always pass through the heater core, or if that was the case, it'd always be hot. That wouldn't be so bad if you were in Alaska. Scan data indicates the starter generator control module, SGCM, by the way, on a GM hybrid pickup has overheated. The least likely cause would be what? Stuck thermostat. Stuck thermostat is not going to have nothing to do. Faulty electric pump might be, an operative fan, low coolant level. Technician A says PTC heaters can be built into conventional heater core assembly. Technician B says PTC heaters' electrical resistance will decrease as its temperature increases. Now wait a minute, what's PTC stand for? Come on, let's talk about that for a second. That's right. And what is that? Does it increase resistance or decrease resistance when it gets hotter? It actually increases resistance when it gets hotter. That's what you expect. That and negative temperature, the resistance decreases when it gets hotter. So remember, get those straight in your head too. Okay, the positive temperature coefficient will be like a light bulb filaments like that. It gets more resistance as it gets hotter. A battery cable's positive temperature coefficient, see? Remember those? Can you remember it like that? What do you say? What was it, guys? What did I say? That's 26, isn't it?
Yeah.
That's going to be an A for like, is it Apple, Alpha, Andalusia, that kind of thing. All of the following statements about hybrid electric vehicle AC compressors are true except A, some use a belt drive along with an electric motor. B, some only use an electric motor without a belt drive. C, non-conductive refrigeration oil must be used with AC compressors utilizing electric drive motor. Or D, most are reciprocating piston designs. D, most of them are actually scroll designs. But your non-conductive refrigerant oil is that, I think they call it ND11 is what they were using for a while. If you put oil in there that eats the windings off the inside of that electric compressor, then you're going to have a high voltage short in there. Because some of the little cars run like 244, 300 volts runs a compressor, but it ain't got a belt on it. It's actually inside, it's just the compressor's hanging there with big orange wires going to it. And whenever you want to turn it on, it spins it up like that. Okay, a device used to turn refrigerant flow on and off in an air conditioning system with multiple evaporators is called a what? Wow, that's something, isn't it? What about a zone valve? Zone valve. If it's got more than one evaporator, What's the optimum operating temperature for an internal combustion engine? Where do you like to see your ice run? Yeah. Huh? About 205. One of the scary things that I always thought was how those doggone, some of them cars will have coolant fans that won't come on before 228 degrees or something. Scare the daylights out of you if you don't know what you're looking at, Okay, let's keep going here. We're almost done. Okay. Number 30, Technician A says, an engine that runs as cold as possible will make more power and will last longer. That's wrong. Technician B says the purpose of the cooling system is to let the engine run as cool as possible. Which technician is correct? That's D, neither one of them. What color is Dex Cool Coolant? Hmm? Dex Cool is actually orange, by the way. And propylene glycol is not nearly as poisonous as ethylene glycol, and so that's one of the reasons they like to go to that. It won't mess up the groundwater like that. Technician A says it's not advisable to add green coolant to a system originally equipped with orange coolant. Technician B says when the ICE is in auto-stop mode, and that's the internal combustion engine, no coolant circulates because the engine does not rotate the water pump. Which technician is correct? That's A. A lot of these hybrids have got electric water pumps on them. Why are the fins and radiators and heater cores so long and flat? Who's talking? Somebody saying? Both A and B, somebody say that? Increased surface area, more air can pass over to dissipate heat. Technician A says the most heat transfer happens when there's a large difference in temperature between two objects. Technician B says the highest engine emissions typically occur during cold startup, before the engine reaches operating temperature. Who's right about that? C is right. Now, what emission is going to be really high when we first start it up? What are we producing? We're producing carbon monoxide, hydrocarbons. Those are the two bad ones. Oxides of nitrogen aren't going to happen when the engine's cold. Carbon monoxide and hydrocarbons are going to happen when the engine is cold. And we'll talk more about that when we take emissions next semester. All right, who's going to be with me next semester? Everybody's hand is up. You're not? Where you? Oh, here you go. Raise your hand. Man, his hands are even greasy, and I need greasy hands with me next semester. Okay, that's it. All right, there you go. All right, let me see here. Let me see. What number am I on? Technician A says because of hybrid technology, the internal combustion engine runs colder than peak operating temperatures. Technician B says PTC coolers located in the AC system are used to overcome this excessive engine heat. Wow, who's right about that? D. 36. We're getting real close. Technician A says the high voltage batteries in all hybrid electric vehicles are cooled and maintained at the same temperature as the engine's coolant system. Technician B says many hybrid electric vehicle high voltage systems are water cooled by separate cooling systems that operate in the same way as the engine cooling system. Now, Technician B is right. You're not going to keep your hybrid battery up that hot at 25, not 195 to 210. You're typically going to have it down really where it's really a comfortable temperature, like between 70 and 80 degrees. Technician A says when a liquid changes to a vapor, heat's absorbed. Technician B says when a vapor changes to a liquid, heat's released. Who's right about that? Come on, guys. We've talked about this before. Don't play dumb with me. What do you think? Is they both right, or is neither one of them right? I have lumps on the log sitting here. We have a lot of lumps on the log sitting here. If I shut up long enough, he'll give me the answer, and I can just go to lunch, huh?
Well, that means there's a good word going and a word coming back.
You got it. If a liquid, when it's changed into a vapor, heat's absorbed. You get out of the shower, you get cold.
Yeah.
Or when you get out of the swimming pool and the wind is blowing, you get cold. Or Technician B says when a vapor changes to a liquid, heat's released. Goes the other way, see? That's why, you know, I talk about, you can tell by the difference of the boiling points of these liquids. If I put alcohol on my hand, it's got a really low boiling point, and it gets really cold. You know how your hand gets cold when you put that on there? But if you put brake fluid on your hand, it actually feels warm. You notice that? Brake fluid or antifreeze? If you spill antifreeze on your hand, it feels warm. You spill alcohol or lacquer thinner or anything with a low boiling point. So the lower the boiling point, the lower temperature the boiling point is, the cooler it's going to make your hand feel when you pour it on there. But the higher the boiling point is, the more, you know, boiling point is higher in water. You know, water feels kind of neutral, you know, but if you go one way or another. Mostly, I don't think about that. But anyway, that's, anybody got any questions or comment? All right, y'all want to take a 65-minute lunch today?
Sure.
Okay.
Time to get out of here.